All right, this is our last section of Unit 6. It's called Perform Similarity Transformations, and we are specifically focusing on a dilation. So this particular topic has a place in a couple units. One is right here, and the other we will come back and look at dilations again when we get to transformations. So it fits in nicely with reflections, rotations, translations, and dilations. So it fits here very well because a dilation, it's an enlargement or reduction, but the two shapes are similar as they enlarge or reduce. Okay, so I actually just kind of started with the definition right here. So it's a transformation that will stretch or shrink a figure to create a similar figure. Typically we would say reduction or enlargement. Number 2 here, in a dilation, a figure is enlarged or reduced with respect to a fixed point called the center of dilation. Now, most of the time when we're on a coordinate plane, we'll be using the origin 0, 0. But otherwise, we won't do a whole lot with the center of dilation in most of our problems. I just want you to have an awareness that it does exist. All right, next. The scale factor of a dilation is the ratio of the side length of a side length of the image to the corresponding side length of the original figure. Okay, a couple items here. Scale factor, you'll see the letter K, the letter used to indicate scale factor. And so we have an image and a pre-image. So the original figure is often called the pre-image. And then the image, I'm just going to write now is the result. Okay, so like let's say we have a shape and we want to make it twice as big. So the original shape is the pre-image. The twice as big shape is called the image. All right, so that's kind of after the scale factor takes place. Coordinate notation. So you can describe the dilation with respect to the origin with the notation right here, this whole thing. Okay, so and we will see this in some examples. So it says for every xy, let's say you've got a scale factor. Let's just say the scale factor is 2. So these k's here are being multiplied by the coordinates. Okay, so for example, we might see something that looks like this. Let's say the point is 2, 1, and our scale factor is 2. So we would have 4, 2 as our new coordinate. Okay, so we are going to be multiplying our scale factor by our coordinate in order to reduce or enlarge it. Okay, lastly right here, if 0 is less than k is less than 1. So if you have a scale factor in between 0 and 1, like a half, a third, a fourth, that type of thing, the dilation is a reduction. Okay, so think about that. If, let's say the scale factor is a half, when I multiply numbers by a half, I get a smaller number, which makes my shape shrink. If k is greater than 1, 1.5, 2, 5, 7, then the dilation will enlarge. Okay, so think about multiplying something by a 2 or a 7 or a 10. You get much bigger numbers. Okay, so we'll see many of these items as we encounter them on examples. Okay, draw a dilation of the quadrilateral ABCD with vertices A, B, C, and D. We're going to use the scale factor of 3. All right, here's where I'm going to begin. So I'm going to, this is our K value. So I'm going to do this coordinate notation, what I highlighted right here. So I'm going to start out and say this. For every xy, I'm going to, this arrow just means I'm going to perform a transformation, in this case dilate. I'm going to take the scale factor of 3 and multiply it by x, comma 3 multiplied by y. So that's telling me that each number should get multiplied by 3. Okay, so I'm going to start this way. I'm going to write my coordinates vertically. So A, 0, 3, B, 2, 3, C is at 3, 1, and then D is at 2, 0. All right, so let's go ahead and do the dilation. So let's dilate each figure. Now, when we write the second coordinate of A, you will see it written as A with this little dash mark. That's called a prime. So A prime, and that just tells me it's not the same as A, it's the new coordinate, it's the image. So I'm going to do the multiplication. So 3 times 0, so what I'm doing here is I'm looking at this. I'm taking this 3 and multiplying by x, so 3 times 0 is 0. And then I'm going to take this 3 and multiply by y, which is also 3. 3 times 3 is 9. So my new coordinate is 0, 9. Let's do that all the way down. B prime. So 2 times 3 is 6. 3 times 3 is 9. C prime. 3 times 3 is 9. 1 times 3 is 3. And then let's dilate D. So D prime would be 6, 0. So it just says to draw the dilation. So let's just plot those 4 points and then connect our quadrilateral. So 0, 9. Let me call it A prime. 6, 9. 1, 2, 3, 4, 5, 6, 9. So here's B prime. I need to do 9, 3. So it's a 10 by 10 grid, so I know that I can go over, almost all the way over to get 9. C prime, and then D prime is 6, 0. 1, 2, 3, 4, 5, 6, and then 0. All right, let's connect it. It's a quadrilateral, 4-sided shape. Okay, and there is our dilation. Okay, so scale factor's 3, and so in a nutshell, when you dilate an item on a graph, all you're doing is multiplying every number by the scale factor. All right, I'd like you guys to pause and do number 2. Find the coordinates of L, M, and N. So the triangle LMN is a dilation of PQR with a scale factor of K. So all that's given to you below. So go ahead, I'm going to graph both, but go ahead and pause the video. I'd like you to write your coordinates down and then make your graph. Okay, let's check. So I'm going to start like this. I'm going to maybe up here write that out. The coordinate notation for every x, y, every point will be 1/5 x, comma 1/5 y. Now, another way to think about multiplying by 1/5, it's the same as dividing by 5. Okay, and that might help a little bit because all these numbers are divisible by 5, so that might be a little bit quicker. Doesn't always work out to be like that, but that is one thing to consider. All right, P, Q, and R. So most of the time I would do P prime, Q prime, and R prime, but I'm going to go ahead and go L, M, and N since that's what I was given. All right, so I need to either multiply by 1/5 or think about it as dividing by 5. So my new point would be 1, 0. M is going to be 1, 1. And then N will be 2, 2. So I'm going to graph both of them just so you can see. So 5, 0. 1, 2, 3, 4, 5. P. 5, 5. Q. And then 10, 10. Here. Let me move that Q out of the way. R. All right, so this is a triangle. Okay, my second one, LMN, 1, 0. Okay, L, 1, 1, and then 2, 2. It's kind of a small triangle. There is M and then N. All right, so you can see when you graph them both, that really good visual. This is a reduction. Notice my scale factor is in between 0 and 1. It's 1/5. So I would expect my shape to shrink quite a bit. Okay, let's keep going. Okay, number 3. Now, we are not on a coordinate plane for number 3. We are identifying the dilation as a reduction or an enlargement. And then we're going to find our scale factor. Okay. All right, so here I want to write this. I'm going to have different letters here. So when I write my scale factor, what I want you to see here, these primes. So what that means is that's the new shape, okay? And the one without the primes is the original. So here's what we want to see. Original, new. And so this is your center, okay? And so then I can clearly see, once I see that this is my new one, it is growing, all right? So it is an enlargement. Okay, so let me give you another piece of notation or formula. I want us to write this down. C prime P over CP. So what I want you to see here, let me switch my colors. So C prime to P is this length, which is indicated by 7. The other one, CP, is what I outlined in blue. That's the distance from the original one back to the center. That is going to be 3. So when you write your scale factor, in my mind, I'm almost thinking of new length over original length, or the enlargement, the image over the pre-image, either way. The other way to double check this is I can clearly tell by looking at this that it got bigger. So my scale factor should be a number greater than 1. So when I do 7 divided by 3, it's 2.3 repeating. That's definitely bigger than 1. Let's say I accidentally wrote this upside down. Let's say I wrote 3 over 7. Well, when I do 3 divided by 7, I get 0.428 and so on, which will make my shape shrink. Okay, so I'm going to kind of circle this part. There's your scale factor there. So K is 7/3. So if you, 2 ways to think of it, I'm always putting the new, or the length from the center of the dilation out to the new image divided by the length of the original. Okay. All right, number 2 here, letter B. Look for your primes. So I have a 4-sided shape here. All right. Not my non-primes right here. D, G, F, E. Okay, so the green is the original. That's your new one. Let me make that a little bit better. So green is original, so it shrunk. This is a reduction. So I want a scale factor smaller than 1. So I am going to think about doing the length from the center to the image, the new one. So let me stick with blue. Let me switch to the other one. So from the center to the new one is 6 units. And then from the center, I'll draw above it, to the original, I need to recognize that I got to add those guys together. So it would be 10. Now we typically reduce down our fractions. So my scale factor here is 3/5. And again, it fits my relationship I expected. A scale factor to be less than 1 because it's shrinking, so I have it in the proper order. Because you could always flip it over if you have it, going the other way. All right, so to get your scale factor, your ratio, you're having a length amount from the center to your new shape divided by center to original. So I always think new over original. Okay, let's just keep going. Number 4, another way to look at a dilation here. A digital photograph has the height shown in the diagram. You want to reduce the size of the photograph to the height shown. What is the scale factor of the reduction? Okay, original, reduction. So if we go back to my idea up here, new over original. Okay, so in this case, the reduction is the new one, 3 inches. The original is 8.5 inches. Now, I can't have my decimal in a fraction, so we need to get that decimal out of there. You could use your calculator. Your calculator has all kinds of buttons to do that for you. Or you could just think about, I'm going to multiply the top and bottom by 10. So when I multiply the top by 10, I get 30, and when I multiply the bottom by 10, I get 85. And the reason I did that is I wanted to move the decimal over one spot, and multiplying by 10 does that. Now reduce this down. So 30 over 85 reduces down to 6 over 17. So there's my scale factor. I don't need units in my scale factor, so I'm just going to write it as 6 over 17. Okay, let's move on. I really have one more concept, and then I'll have you guys do the last example. You want to create a quadrilateral ABCD that is similar to FGHJ. What are the coordinates of point D? All right, I have FGHJ. I have ABC. So I know it's going to be somewhere, you know, over here. So I want to consider that I'm trying to figure out that scale factor. Okay, so remember, I'm trying to figure out for every coordinate, some number got multiplied by x and the same number got multiplied by y. So let's see what's going on with the 3 I know, and then I'll apply that idea to the 4th. Okay, so I'm going to go from A to F. So let's count out A. A is 1, 2, 3, negative 4, comma 0. It was reduced. Nope, actually I have this backwards. I want to go F, G, H, and J is the original one. So let's back up. Let's start with F. So it's enlarging. All right, so F is negative 1, 0. F was enlarged to the point negative 4, 0. Now, when I look at that, what number did negative 1 get multiplied by to create a negative 4? That's what I'm trying to figure out. Zeros don't really help me. All right, let's write a couple more out. G is at 1, negative 1. It was enlarged to B, which is at 1, 2, 3, 4, and then negative 1, 2, 3, 4. Positive 4, negative 4. All right, positive 1 to 4, negative 1 to negative 4. So it's looking like we're multiplying by 4 here. Okay, let's just make sure. H turned into C. So H is at 0, 1, negative 3. And then C is at what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually 0, negative 12. So negative 3 times 4, yeah, that's negative 12. All right, so my scale factor is 4, so that's going to help me create point D. All right, so J is at 1, 2, negative 2, 1, 2, 3, negative 4. So D, I'm going to multiply by 4. So that means I'm going to be at 8, comma, negative 8, I'm sorry. Negative 8, comma, negative 16. So it's going to run way off my graph here. So I'm just going to outline D. So negative 8, negative 16. So you may not have had to write all of those out, but I just want you to see that in order, because it is a similar figure, that scale factor will apply to all of your coordinates. All right, I'd like you to stop the video and try number 6 on your own. It's a little bit like the one we did before this dilation here. And then when you are ready, come back and check. Okay, original 7.5, you want to reduce it to 2.5. Okay, so this is the original, new. So I'm going to situate my factor as my new over original. Because what I should be able to do when I'm done is multiply this factor by 7.5 and create 2.5. So let's get it into a more usable factor. I'm just going to multiply both top and bottom by 10. So that will reduce down to 1/3. So I should be able to take 7.5, multiply by 1/3, and create 2.5. That's how I'm going to know it's correct. Okay, well that covers our dilations unit, or not unit,